Hey everyone, I'm Dr. Surjit Singh. Today we'll talk about the Leetcode problem, Android unlocking patterns. This is an interesting problem on backtracking. Let us begin. Android unlocking grid consists of 9 dots. User can set a sequence of dots as their locking code. Note, sequence should conform to a set of rules and a dot cannot be selected twice in a pattern. Given two integers m and n, we are to find the number of unique and valid unlock patterns of the Android grid lock screen that consists of at least m keys and at most n keys. Our algorithm is based on backtracking. Android lock grid consists of 9 dots numbered from 1 to 9, whose indices are from 0 to 8. In this example, we fix 1 to 2 as the range of the lengths of the patterns to be drawn. Used is the list that records the indices of the dots used in the pattern. In the beginning, none of the digits are used and all of these are false. First of all, we construct a function isValid to understand which of the moves between the dots are valid. The move under consideration is from last index to index. Last index is the index of the dot where the previous moves of the pattern had ended. Let us understand an important restriction. A move such as 0 to 2 as shown here is not allowed because it passes through another dot that is not already used. However, if the dot lying in between is already used, the move is allowed. After the move is made, we will set use2 also to be true. With this in mind, we start developing the isValid function. If last index is -1, it means we are starting with a new pattern and the index is the starting position of the new pattern, which can start from any dot. So this is always allowed and we return true. If a dot has been previously used, it cannot be reused. Moves between odd and even indices do not pass through any dot in between, so they are always allowed. A few such moves are shown here. All the remaining moves are from odd to odd or from even to even. In this case, we find the middle of the two indices. If mid is 4, it means that the two indices are one of these. This is allowed only if the middle number is already used, not otherwise. So we return used mid. If move is one of these, it is always allowed. The remaining four are these moves. They are allowed if their middle dot is already used in the path, not otherwise. We now start with the main function and define result equal to 0. In the first iteration of the for loop, length of the pattern is 1. In this case, we will find patterns consisting of one dot only. We call the function calculate pattern for given length. The function calcPatterns receives two parameters. In this first call, only one is given, so last index gets the default value of -1, which indicates the beginning of a new pattern. The edge case of recursion is len equal to 0, for which the only one choice is the blank pattern. In the recursive part, we define sum equal to 0. We loop over indices of the digits of pattern. Starting index is 0. The move from -1 to 0 means beginning of a new pattern starting from index 0. IsValid returns true. We mark used index as true. After selecting the dot, we make a recursive call for the remaining length in which present value of index becomes last index. As the remaining length is 0, which is the edge case, so this call of the function returns 1, which is added to sum. The requirement of backtracking is that we restore false for the dot before finishing the call. Next value of index is 1. This will start a new pattern from 1 and isValid is true. So we assign used 1 to be true. Next call of calculate patterns has length equal to 0, so it returns 1, which is added to sum whose value becomes 2, and we reset used 1 as false. The process continues. At the end of for loop, sum becomes 9. We return sum to the main function and 9 is added to result. Next value of length is 2, in which we will generate patterns of 2 dots for which calculate pattern is called with length equal to 2. Last index gets the default value of -1. Sum becomes 0 and initial value of index is 0. The pattern trying starts from 0 and is valid returns true. Used 0 becomes true. In the next call, length becomes 1 and the index of previous call becomes the last index. Sum is 0 and starting value of index is 0 in this call of for loop. We again call is valid, but used 0 is true, which means that this dot is already used in the pattern and cannot be used again. So is valid returns false and if statement of calculate functions is skipped. Next value of index in this for loop is 1. Move from 0 to 1 is valid, so we mark used 1 as true. In the next recursive call, len is 0, so it returns 1 which is added to sum, and used 1 is reset as false. In the next iteration, index becomes 2. Move from 0 to 2 is not valid because it passes through 1 which is not used. So we skip the if statement. Next index is 3. Move from 0 to 3 is valid, so we mark 3 as true. Next call has length 0. It means that 2 dot path is complete. This is also added to sum. Sum becomes 2. We reset used 3. Index now becomes 4. The move 0 to 4 is valid. We set used 4 as true, increase sum by 1 and reset used 4. Two more moves 0 to 5 and 0 to 7 are valid, so sum becomes 5, which is returned to the previous call and added to its sum. Next, we reset used 0. In the next iteration, index becomes 1. As it is a valid starting point of next few patterns, we mark used 1 as true. Next recursive call has length equal to 1. Starting from 1, the valid moves are to all the dots except those with indices 1 and 7. So final value of sum will be 7, which is returned. This is added to sum, which becomes 12. Similarly, each dot will become the starting point and the total number of 2 dot patterns will be 56, which is returned to the main function and added to result. 65 is the final value of all the patterns of lengths of 1 or 2 dots. Time complexity depends upon the number of patterns computed. If n is the maximum length of the pattern, time complexity will be n factorial. Symmetry considerations can reduce time. For example, number of patterns starting from 0, 2, 6 and 8 are same and only one out of these need to be computed. Similarly, 1, 3, 5, 7 have symmetry, hence we only calculate one among each group and multiply by 4. Height of the call stack is n, which becomes the space complexity. I hope that you found it useful. Thank you for your time. Please stay tuned for more such interesting problems.